Welcome to The Explainer. Sometimes to really understand how something works, you've got to push it to its absolute limit. So today, we're going to the summit of Mount Everest, one of the most extreme places on Earth, to uncover the incredible, hidden systems that are constantly working to keep you alive.
All right, so picture this. You're there, the cold is biting, every single step is a huge effort, and the air, well, there's barely any of it. How does your body even begin to cope with that? It's not just about hiking. It's this unbelievable second-by-second performance your body is putting on, fighting to keep you alive against some pretty insane odds.
So before your body can do anything, before it can react, it needs a mission, right? A single guiding principle for every system, every single cell. And yeah, that mission has a name.
And that mission is homeostasis. This is your body's one and only job. Its ultimate, non-negotiable goal: maintain internal balance. No matter what's happening outside, it is working tirelessly to keep everything on the inside. Your temperature, your blood pressure, your oxygen levels, within this incredibly narrow, life-sustaining range.
The easiest way to think about it is like a smart thermostat in your house. You've got a receptor, that's a sensor, and it notices a change. Hey, it's too cold in here. Or in our Everest scenario, whoa, there's not enough oxygen. That sensor sends a signal to the control center, your brain. The brain analyzes it, figures out what to do, and then sends a command out to an effector, a muscle or an organ, to actually fix the problem. Sense, decide, act. It is this constant, non-stop loop. Okay, so when you're on Everest and things get dangerous fast, your body doesn't have time to sit around and have a committee meeting about it. Nope, it deploys its elite rapid response team and it does it instantly.
And the first one on the scene, the absolute command center, is your nervous system. Think of it like the body's super high-speed internet, sending these tiny electrical signals that make everything else happen in the blink of an eye.
Now, within that nervous system, it's the autonomic part that's running the whole show behind the scenes, without you even having to think about it. And it has two modes. Normally, you're in rest and digest mode, the parasympathetic system. But on Everest, forget about it. That gets put on hold. Instead, the fight-or-flight system, the sympathetic division, slams its foot on the gas pedal, flipping every single switch into full-blown survival mode.
So what's the first thing that fight-or-flight system does? It makes an emergency call to its two best friends, your respiratory and cardiovascular systems. Their joint mission, their only mission at this point, is to solve the number one biggest threat up there: the critical lack of oxygen. Just think about it. Right now, wherever you are, you're probably breathing maybe 12 to 15 times a minute. It's calm, it's steady, you don't even have to think about it, it's just boop, automatic.
But up on Everest, that gentle rhythm is completely gone. Your body flips into a state called hyperpenia. Basically, your brain forces your lungs to go into overdrive, dramatically cranking up your breathing rate. You're just trying to pull every last molecule of oxygen you can from that thin, unforgiving air.
And at the exact same time, what's your heart doing? Well, normally, it's just ticking along, maybe 75 beats per minute or so.
And at that rate, it's pumping a little over 5 liters of blood around your body every single minute. I mean, think about that. That's your entire blood supply making a full lap of your body every 60 seconds. Pretty amazing, right? But here's where it gets really cool. When that fight or flight signal hits, your heart doesn't just beat faster, it beats harder. Each individual pump, each contraction is way more forceful. This just dramatically increases your cardiac output, so it can rush whatever precious oxygen your lungs manage to grab straight to your starving brain and muscles. Okay, but all of this is like an emergency sprint. And that's not enough, is it? Climbing Everest is a brutal, high-stakes marathon. So the big question is, how on earth does your body sustain this crazy high-alert state for hours or even days on end?
Well, this is where the support crew shows up, your endocrine system. See, while the nervous system is all about those lightning-fast electrical signals, the endocrine system plays the long game. It uses slower chemical messengers, hormones. It sends out things like epinephrine to keep that heart rate jacked up, and cortisol to start unlocking your body's energy stores, giving you the fuel you need for that long, long haul.
So let's recap. We've got the nervous system, the respiratory system, the cardiovascular system, and the endocrine system, all of them working at full throttle. But here's the most amazing part. They're not just working at the same time, in parallel. They're in constant, complex, intricate communication. It's like an orchestra.
And the true genius of the human body, the real masterpiece,
is how all of these systems are integrated. The communication is just so precise, and it's almost all managed by this beautifully simple, elegant idea called a negative feedback loop.
And this, right here, this shows you exactly how it works. Look at step 1. The stimulus, that's the problem, is low oxygen. Okay, so receptors in your arteries detect this, and they shoot a signal to the brain. The brain processes it and sends a command out to the heart. The heart responds, right? It starts beating faster. But here, and this is the absolute key, look at step 6, the result. The faster heart rate raises your blood oxygen levels, which removes the original problem. The system fixed itself. And because the problem is gone, the signal stops, and the system can dial itself back down. It's this perfect, self-correcting, self-regulating loop.
So when you boil it all down, what's the big takeaway here? It's this. Your body isn't just a collection of parts, like a bag of organs that just happen to be in the same box. No way. It is a single, dynamic, deeply integrated masterpiece where every single system is in perfect, harmonious communication, and it's all for one goal: keeping you alive.
And that really leaves us with a final thought, doesn't it? Because this whole thing, it isn't just about climbing a mountain. This incredible physiological orchestra is performing inside of you right now. As we're talking, it's managing thousands of different variables just to maintain that perfect state of balance. It really makes you wonder, what else is your body doing right now without you even having a clue? Thanks so much for joining this explainer.